Hello, everyone. This is Mehmet Toy from Verizon. Topic of my talk is the virtual networks and services and their automation. I would be first covering the layers for virtual systems, and then describe the virtual systems and services, their high availability, and their network model, or I shouldn't say network model, but really the model for the networks and services, and also the management architecture, and then the automation. Virtual systems layers, I'm sure most of you are familiar with it, is the NFVI layer at the bottom that consists of hardware, operating system, virtualization layer, VM layer, VNF layer, the container layer, and then on top of that you have VNF. So I think most of the folks are familiar with the NFVI layer and then VNF layer on top of that, which is really a ETSI standard. But what I have proposed is we need another layer, that is the connection layer or session layer on top of it. And actually, there is a specification E016, ETSI E016, that I have edited that covers the connection layer as well. So the figure below summarizes that you have basically an NFVI layer, VNF layer, and connection layer. Now, each of these layers can support data plane functionalities, control plane functions, and management plane functions. And we expect each layer to have a API. An API, hopefully, a standards API. So if we have an NFVI layer, we would like to see the NFVI API. And if we have virtualization layer, we want to see the virtualization layer API. And the reason is if we want to build a virtual system from different vendors' products, then this is the only way to do. That is, you will have standard APIs, and then you will have mix and matches from different vendor products to build a virtual system. The figure on the top, on the left, is showing the interfaces to a virtual layer, virtual system layer. First of all, the virtual system layer needs to have APIs to talk to the layer below and layer above. So we call it northbound API and southbound API. But also the layer needs to have interface to a user, so that they should have a user interface API, and also interface to a management system. So we call it management interface API. For example, if you look at NFVI, NFVI is the lowest layer in the virtual systems. So it will have an API for northbound API for the VNF layer, and also has APIs for the user and the management interfaces. The right figure on the right side is really showing the virtual system as a black box. So you have a management interface on the right side and the user interface on the left side. Now, management interface really deals with both NFVI and the VNF. And of course, it will also deal with the connection layer, which I don't show over here to avoid confusion. But on the left side, as you can see, user deals with application, and also user deals with the connection layer. Now, if we look at the attributes for let's say the virtualization layer, for the northbound API, we would like to see, for example, number of virtual CPUs, amount of RAM, for example, or amount of peripheral ephemeral storage. We would like to see the amount of persistent storage or virtual mix. And then we see if we have some maybe accelerators support, like DPDK is supported, or maybe CPU pinning is supported. And of course, you also would like to have the event reports. If there are failures with the memories or the virtual NIC, or with the let's say DPDK support, you need to have those failure events so that you can report to the higher. Now, this is an example. You can have more attributes than this. Similarly, if we look at the management API for the same virtualization layer, you see a lot of parameters are the same, except if you look at from the bottom, maybe management interface would like to see the utilizations. Utilization of the, let's say that the CPUs, the maximum, average, minimum, or maybe the memory utilizations. And also, it may have to pay attention to the redundancy. So whether it is active redundancy or is it active standby redundancy, and so on and so forth. So my point is those attributes, those interfaces have to be standardized for all layers and for all these interfaces. Now, there are at least there will be some efforts, hopefully, I'm hoping in the MEF that we will define those. Now, if we look at the overall network, as you can see at the bottom, you have, let's say, virtual CPEs at the customer premises. And then at the top, you have data centers, and in between, you have WAN. And the layers for the virtual system at the customer premises and in the data center are the real same. So you have infrastructure layer 1, the VNF layer, VM layer, and so on and so forth. As you can see, I have labeled the infrastructure layer for the CPE as infrastructure layer 1 and for the network as infrastructure layer 2. And assume again this is the legacy network, and so it's called as an infrastructure layer. Now, one of the key properties of the services that as we service provider support or provide is really the high availability. We want to make sure our virtual networks and the services that we provide is highly available. Now, for high availability is a little bit different in the virtual systems. How different it is? If you look at this virtual CPE or the CPE, if it is a monolithic system, that is the, let's say I have a legacy router or legacy switch. If the switch fails, I switch to another switch, or if the router fails, I switch to another router. In other words, I might have the active or active standby. So I will have the redundancy pair so that I can switch to the redundant pair. Now, in the virtualization, the virtualized systems, that's not the case. Each layer will have its own redundancy. So if I have infrastructure layer, it will have its own redundancy. VM layer may have its own. VNF layer will have its own. So if you don't have the synchronization among those layers, I think we will end up with the issues. Issues in the sense that while one layer is switching from fail to the active, the other one maybe try to go the other way around. So you go back and forth between the failure and the active mode. So for that is we define the high available layers or highly available layers. For them is we call them highly available is, let's say if it is an infrastructure layer, the hardware layer, we expect them to have a redundancy. And at the same time, we want them to be able to detect their failures, recognize their failures, and report that to the appropriate management systems and also the layers above. Now, this logic basically goes for all the layers. So virtualization layer, I expect the same thing. VNF layer, again, we would like the same thing. And so is for the connection layer. We want them to be redundant. And again, if there are failures, we want them to be detected, reported properly, and also to switch over to the redundant unit or redundant layer. So how do we provide the synchronization. So it's one thing is very clear, right? That the failure recovery time, which I'm going to describe later in a figure, failure recovery times for the layers shouldn't overlap. And what really that means is, let's say I have a failure at t is equal to T1. And if t is equal to T1, maybe sometime later, let's say that failure takes place in the infrastructure layer, that failure will propagate to the higher layer. So, and let's say that the both layers, once they, of course, recognize the failure, they try to switch over. If they switch over that, then we will end up with the issue that I just mentioned. So because of that, let's say that the failure recovery time for the infrastructure layer 1 is T11, for VM layer is T2, VNF layer is T3, infrastructure layer 2, which is if you remember, the WAN access and core network, that failure recovery time is T4, and then we have connection layer recovery time is T5. And assume that they are in supports this equation one. It doesn't have to be. In other words, what I mean by that is maybe the sequence will be different. It may not be T11 less than T4 and less than T2, T3. Maybe T11 less than T5 and then and maybe the T3, T11 less than T3 and that less than T2, T4. So there could be some, the sequence could be different depending on the implementation. But also I introduced another timer, which is T12. That is the following. So assume that the highest failure recovery time is T5. Then I would like to see if none of these failure recovery times works in any of these layers. We need another watchdog. In other words, the infrastructure layer should take the ownership, and if none of the layers above works, then it should switch over the system. And for that is you need to do really two things. One is you need to generate reports, of course, event reports, and you need to store them in a system. And once you need to store them in the system, you need to also check them periodically. So that is periodicity is TP. And if that, while you're checking periodically, then you find out there is a failure, and then you want this, the failure recovery initiated by the network function layer, I'm sorry, the INF layer, and that is the timer T12. So as an example, let's say that the T5, which is in this equation one, is the highest failure recovery time. Let's say it's 500 milliseconds. And the beta is, let's say, 100 milliseconds. So therefore, I'm expecting that the infrastructure layer 1, if none of these failure recovery procedures work, then infrastructure layer 1 is going to switch over after 600 milliseconds after the failure initiated. Now, at the same time, the periodicity, which is the checking the syslog periodically, that TP should be between the smallest failure recovery time and the largest, which is the T12. Now, of course, it shouldn't be really close to T12. There should be some, it should be quicker.